let me go over just a few minor announcements, just to let you know. I've got a few temporary changes to my office hours. It'll just be this week and next week. But then one permanent change for the rest of the term, okay? I think I already told you about that one, but I'll go over them all again. Because I had a doctor's appointment yesterday, I missed 45 minutes, would have missed 45 minutes of my Math 112 class. I missed all of my 113 class. Okay, now, with that, because of that, the 112 class and I decided to make up those 45 minutes by having 15-minute longer class yesterday, so I started at 8:15 rather than 8:30, and then we'll do that again tomorrow, and we'll do it next Tuesday. So normally I've been in my office between 8 and 8:30 every morning, but not tomorrow and not next Tuesday. I'll only be in there from 8 to 8:15 because I'll be starting, actually I'll leave there before 8:15 to start the class at 8:15. But after next Tuesday, that'll be through. Now, my trig class that I missed completely, we decided to make that one up on Friday, day after tomorrow. And that will be 9 to 10:15. I'll be in that class in this room. So if I can get away with it, I'll be on this campus before and after that. But if I have to go to the Birmingham campus, I'll either swing by there on the way in and then have to drive here before 9, or after the class, swing by there and work the rest of the day there. I'm hoping I don't have to make those trips because if I do either one of those, then that's every trip is about a half hour that I can't get work done, so because I'm driving. So if I can get by without driving, I'm going to stay on this campus. But if they want me there before and want me there after, there goes an hour of my 4-hour work day. And I have an hour and 15 minutes in class, so now I'm minus 2 hours and 15 minutes, so I only have an hour and 45 minutes left to do any work. So I'm hoping that's not going to be the case, but it might. If they need me to be there, I'll have to go there. Okay. Now, those are the temporary changes. That's for this Friday only. I'll be on this campus at least for part of the time, hopefully all the time, but I will not be in office hours for that 9 to 10:15. All right, then the permanent for the rest of this term change is that my second mini-term physical science class starts at 3:15 rather than 1:15, like the first mini-term did. So that means on Tuesdays and Thursdays, my office hours, they used to be 11:15 to 1:15, now they're 11:15 to 3:15. So I have 4 hours of office hours rather than 2, but that also means I'll be here until 7:45 at night, okay, on Tuesday and Thursday, which actually it's closer to 8 o'clock that I'll be leaving because the class goes until 7:45, and by the time I shut everything down, get everything doing its thing, at least 8 o'clock before I leave.
Long day.
Yeah, 8 to 8. And usually I'm here before 8 in the morning, after 8 in the evening on Tuesday and Thursday. Okay, that said, any questions on anything we've done so far, any other things that are happening? Let me get my setup for the current slide. Okay, no questions. Let me get my pen set up. Okay. All right. Now, as we started chapter 7 last time, by the way, I guess I didn't make this announcement on once I got Screencast-O-Matic started. For people listening at home, I do have your chapter 5 test ready. I've given it to the people that are here. If you're not here, come by and pick up the chapter 5 test. Okay. All right, in chapter 7, we just got started, got the first page done, so we're at the top of page 445 and 7.1. 7.1 is area of a region between two curves. And here is the statement about the area of a region between two curves. If f and g are both continuous functions, we don't have them being discontinuous on the interval a to b, but if they're both continuous functions on that closed interval a to b, and that g of x is always less than or equal to f of x for all the x's on that interval a to b. Now, outside that, doesn't have to be, but inside that interval, they have to be, g of x has to be either less than or could be equal to f of x at any point on that interval. Then the area of the region bounded by the graphs of f and g and the vertical lines x equal a and x equal b. That area is the area is the integral from a to b of f of x minus g of x dx. Okay? Now, if you think about this, in terms of, and that's what they're going to show next, in terms of the way we do things like this, in this figure, the graphs of f and g are shown, and so notice f is always greater than or equal to g inside this region, a to b. You can even extend a out to here where they'd be equal, or the b over to here where they'd be equal. This would work. Anything outside of that, now f is less than g, or f is less than g here, can't work there. So it's only where f is greater than or equal to g. Okay? And it says here the graphs of f and g are shown above the x-axis. That's not necessary. And that's what I kept saying before. This whole thing should have been down here, part of it here, anywhere that you want it to be. You don't have to be above the x-axis anymore. Okay? Now, they talk about the integrand can be used as one blah, blah, blah. Here's how I like to look at this, okay? That area in between the curve can be represented as a number of strips, remember? Okay? And obviously that strip is a thickness of dx, right? Or delta x, okay? That's just the width of the strip. Well, what's the height of that strip? Isn't that f of x, the y value up here, minus g of x, which is the y value down there? That's the length of it. So the integral, which sums all those strips together from a to b, x equal a to x equal b, the length times the width, there's your integral. So think of it that way. It's just like we've been doing before, okay? That's what the area is, that integral, and that's why. The same integrand, f of x minus g of x, can be used as long as f and g are continuous and that g of x is less than or equal to f of x for all the x's on the interval a to b, which is what the previous slide said, okay? If you got outside that, then you have to stop and do something else. But if anywhere that f is always greater than or equal to g, this will work. Okay? Make sense? Now, that's summarized graphically in this figure, which is now showing what I just did. Notice in this figure, the g can be less than 0. That doesn't matter, okay? Or the f and g can be less than 0. That doesn't matter because the length of this is still the y value here minus the y value there. This just happens to be a negative y value, so it's this y value minus a minus, which is plus this y value, the absolute value of it, right? Or if they're both down here, it's this y value minus this one, and that's still a length. It's just a small negative number, subtract a larger negative number, minus a big minus number, that gives you a length. So it works. It doesn't matter where it is relative to the origin, as long as f is greater than or equal to g, which is here. The book keeps saying g is less than or equal to x. It says the same thing. I just like to name the top one first. It's going from a to b. As long as in that entire interval, f is always greater than g, it's fine. Okay? So that the height of the representative rectangle is the same wherever you are, okay? The rectangle didn't change, so the area didn't change. Make sense? Okay. All right. Representative rectangles are used throughout this chapter in various applications of integration. So we'll be using those, get used to them. A vertical rectangle of width delta x implies integration with respect to x. Whatever your delta is, that's what your limits have to be. You're integrating with respect to that. If the problem would have been better with a delta y, then you have to have the functions in terms of y, everything in terms of y. Okay, that implies an integration with respect to y, and then it'll be from y equals c to y equals d, whatever those values are. All right, so here is example 1. Find the area of the region bounded by the graphs y is equal to x squared plus 2, y is equal to negative x equals 0, and x equals 1. Okay? Now, I know what the x equals 0 and x equals 1 is going to be. That's going to be our two ends. What we got to figure out is who's on top here. Okay? Is that first y on top, or is the second y on top? And here, second.
I was going to say it's got to be the first one.
Okay, why?
Because it's a parabola plus 2 and the other one is a negative.
Okay, so it's always positive. The x squared is never negative, and add 2 to it, it's always positive. Whereas y is equal to minus x, that starts at 0 and goes down. So yeah, that's going to be negative between 0 and 1. 0 at 0, but negative everywhere else. So yeah, this is the one on top. So what would be the area of that region?
It would be x squared plus 2.
Okay, the integral of x squared plus 2 minus
negative x,
which would be a
positive,
plus x
dx.
dx. Okay,
Over
0 to 1. Perfect, done. Okay, now guess what? You don't have to have the integrand in you don't have to have the integrand in decreasing order of your powers. There's no real reason to, so we can integrate it just like that. But if you really like it, you can rearrange it and make it x squared plus x minus plus 2. It really doesn't matter. You're just going to be integrating it anyway. So what does that integral come out to be? What's the antiderivative of x squared?
x cubed
Over 3, perfect. How about 2? Or do you want to do x next? I don't care.
2 would be
2x.
And the next is x squared over 2.
X squared over 2. And we evaluate that from 0 to 1. Okay? I'll do the 0 part. Y'all do the 1 part. What you get? It's really awfully easy too.
The
1/3
plus 2
plus 2.
plus 1/2.
Okay, I'll do the 0 part. Plus minus 0, minus 0, minus 0. Okay, I did it. Y'all follow that? Do I need to slow down a little bit? Okay. All right. What's that?
Show the steps on that last
Yeah, okay. And what does that turn out being? Y'all love your fractions, don't you?
It would be 17/6.
Okay. I believe you're right. 17/6 he said, which would be 2 and 5/6. Yes, absolutely correct. Okay? Because 1/3 is 2/6, 1/2 is 3/6, 2/6 plus 3/6 is 5/6. Add 2 to it, 2 and 5/6. And that's 17/6. Perfect. That's what they got too. Now, I bet you they're going to do a little bit more than we did. You need this up here a little longer, or you want to just see what they did? Got it? Okay. So, they let g of x be the negative x and f of x be the x squared plus 2, just like you did. Because, like you said, x squared plus 2 is always positive, and the g is equal to, second part, y is equal to negative x, is 0 or negative. So, therefore, the f is the greater function, g is the lesser function. So, they drew the picture here. There's your, as you said, that's your parabola. Raised up by 2, so its vertex is at 0, 2, and it goes up from there.
Would that ever,
Second?
even like way out there, would the parabola ever flatten out enough for the y equals negative x to cross it?
Okay. On this side, I don't think so, because that's going up faster than this is. On this side, that's going down, so it's never going to happen there. And since this is going to have a larger and larger value here, this is a linear large out. It's never going to happen. So you could have set the limits anywhere there and done the same problem. Okay? So that's our setup. Boy, they made a big delta x here, didn't they? Okay, there's your delta x, and your length of that rectangle is F minus G, which is the same as F plus the opposite of G. Okay? So, which is what you get when you do F minus G, F minus minus is plus. So you integrate from x equals 0 to x equals 1. 0 to 1. So here's your delta A. That's an interesting way to express it, and it's perfectly fine. Your incremental area would be the height times the thickness being delta x, and then you integrate that, or you plug in what those are, and your area then would be the integral of that, integral from a to b, which in our case is 0 to 1, of f of x minus g of x times dx, and that would have been integral of 0 to 1 of x plus x squared plus 2, that's your f, minus your g was negative x, and they're stringing this on as long as possible. That would be, and then they did the integral, they rearranged, did the integral, and just got that far. Show all these steps in gory detail and then skip a bunch, so anyway, that gives you exactly what we got. They put it in descending order of powers, and that gave 1/3 plus 1/2 plus 2, and that is 17/6. I would have said 2 and 5/6, but that is the same as 17/6. Any questions? Sorry, I've got the yawns. My head is clogging up on me. All right, that was example 1. I'm losing my throat. Now let's move to an area of a region between two intersecting curves. And that's, Clark was looking ahead to this because he was saying, will those two ever intersect? Well, these will, okay? In example 1, the graphs do not intersect and the values of A and B are given explicitly. But a more common problem involves the area of a region bounded by two intersecting graphs where the values of A and B must be calculated to see where those points of intersection are. And that's not a hard thing to do either, okay? So here's example 2. It says find the area of the region bounded by the graphs of f of x equal 2 minus x squared and g of x equal to x. Okay. Now, one way to do this is to draw the graph. Gee, I don't like drawing graphs if I can avoid it. Okay. So what do we need? If it's a region bounded by the graphs, what's going to be the A and the B? That's
Points of
where the
intersection?
two graphs cross, where the points of intersection. And what's going to be true about the points of intersection? Well, let's just draw some made up kind of thing here. Okay, say it was something like that. It's probably not. Okay, what are these 2 points of intersection? There's one and there's one. What can you tell me about those 2 points? Say this is our, that's not the, let me get it a little more realistic. Ooh, that didn't work. All right. Okay. I don't know why I drew it backwards. Okay, that's more realistic. Here's the 2 points of intersection, there and there. Okay? What's true about those 2 points? This is your F, and this is your G. What can you tell me about both of those points? One statement is true about both of them.
They have the same slope.
Second?
They have the same slope.
Same what?
Slope? No, that's
No,
that's
definitely not. This has a slope here. That was close to it. This has a slope downward, and that's nowhere close to that.
I was thinking of the linear line, but that's not the point. Exactly. That's
Okay.
not the line.
Okay, you're getting close. The point of intersection is the same, right? In other words, your f of x is equal to g of x here, and f of x is equal to g of x there. They're the same point, so they got to be equal. So that's what we got. That's how we get this. So forget my ugly picture. Hopefully it helped a little bit. But what we're looking for is the bound, the end points, those are the places where they equal. So I don't know why my pen didn't come back. There we go. Okay, so we're looking for the places where f of x is equal to g of x. Remember back in pre-calculus algebra, that was one of the things they had you do when they're getting playing around with functions. This is why, because you're going to need it here. So your f of x is 2 minus x squared, and that's equal to g of x, which is just x, right? Let's solve that. How would you go about solving it? Subtract what?
The x over here.
Okay, you certainly could do that. Now, I don't like it doing it that way, and here's why. I like my leading coefficient to be positive if I can have it. You don't have to. I'll just like it that way. So in this case, I'm going to add x squared to both sides and subtract 2 from both sides because I want 0 on one side and my quadratic on the other side. Now I'm going to flip sides. This adds to 0, so we have x squared plus x minus 2 is equal to 0. Now what can you do with that? Factor! All right, okay. Now you see why we learn factoring, right? How does the first factor? X times x.
No.
Second? Second? Okay. One's going to be a minus, one's going to be a plus. So you want two numbers because those are different signs. They're different signs because that's a minus sign.
You want a positive 2 and a negative 1.
A positive 2 and a negative 1. Perfect. Okay. And let's just check it, make sure. X times x is x squared, plus 2x minus x is plus x minus 2. Yes, that works. So what are our two values? Oh, what? Second. X equal 1 or x equal negative 2. So I want my A to be negative 2 and my B to be 1. Okay? All right. So now, the other issue is who's on top. Okay? Because you need to know which of these functions is greater. Well, this is the interval we're interested in from negative 2 to 1. Can anyone think of a number in between negative 2 and 1 that would be pretty easy to plug in? 0. I like that too. Plug in a 0 for your f, and what do you get? Second. Plug x equals 0, and what do you get? Second. 2, right? Okay. Plug x equals 0 there. 0. Who wins? This one does. So F's on top, in between those two. Outside those two, F's on the bottom. Okay? But it's in between those two, F's on top. Okay? So now we know who to put first. All right? So what would be your area? Help me. Help me, help me. Okay, 2 minus x squared. Minus x.
And you have to do the integral between -2 and 1.
Okay.
Oh, and the dx.
Ah, dx you said? Oh yeah, there's the thickness of it and there's the length. Okay? Now, you don't have to rearrange this. All we're going to do is integrate it. And what would that be? Antiderivative of 2. Antiderivative of 2. Okay, I can't hear, sorry. What's the antiderivative of 2? 2x. Is that what you said? I couldn't hear. Okay. It's 2x minus antiderivative of x squared. X cubed over 3 minus the antiderivative of x.
Which is x squared over 2.
Okay. We're going to evaluate that from negative 2 to 1. Okay?
Should that x be a plus?
Which one? I thought it was f minus g. Okay. Okay. You want it to be like the last one so you didn't have to work it hard. Okay. No, you have to work hard. Okay. So let's plug in first the 1. I'm going to let you do it. And what do you get? Help me, help me. Say again. 2 minus 1/3 minus 1/2. And when you plug in the minus 2, what happens? Minus a negative 4.
And then plus.
Okay. If you're going to have the minus outside the parentheses, then keep your signs.
Well, actually, I changed mine.
Okay, so you just did that. Okay, that's fine. Okay, now it's going to be plus or minus or what? Plus.
8/3.
Oh, it's going to be a minus 8/3, isn't it?
Well, see, I did plus 4.
Okay, plus 4. Okay. Okay. Let me show you two ways of doing this, okay? All right, we did the first one, plugging in a 1, leaving the signs alone, okay? Now, and you can do this any way you want to, but then it's minus plugging in the -2, and let's just do that, plug in the -2. That'd be 2 times a -2 minus a -2 cubed over 3 minus a -2 squared over 2. Okay. Isn't that what we're doing here? The first one, positive, minus the second one plugged in. And here's this. Okay. We're on example 2 at the top of page 446. Okay. Now, I'm going to scoot things over left a little ways. So this would be a 2 minus. Now I'm going to go on and get at least common denominators. Is that okay? So that's going to be 2, 6 minus 3, 6. Okay with that? All right. Now, I'm going to leave that minus sign in front for a bit and deal with my signs as I get to them. And 2 times -2 was? -4. And then we have a minus times a -2 cubed. And what's -2 cubed?
Minus -8/3.
Okay, -8/3. And you have minus a negative. Okay, let's write it down. But minus a -8/3. Okay. And then you have a minus again. And what's that going to be?
-4/3.
Okay, not negative because that one's squared. So that's going to be -4 halves, right? Okay, yeah. All right. Okay. I guess I was putting pressure on something without realizing it. I don't know if y'all recall, several weeks ago, my chair caught the cord here and pulled the computer onto the floor. So the student who looked at it said she thought probably some damage had been done in there. So there could be a little short there. So that might be what was happening. All right. Woo-wee. All right. This is going to be 2 minus 5, 6. I'm just going to go and subtract that. Ah, okay. Good to see you. Jordan's here. Still missing Charles and Catherine. All right. And I'm going to put the minus sign again and keep this in parentheses. That's going to be a -4. Then minus a minus is a plus 8/3 minus 2, if I did that right? Okay. Now, I don't care how you do this. You can do it any way you want to. But it seems like easy to me to do 2 minus 5, 6. Do a minus times minus is +4 minus, well, let's get that into 6 as well. That would be 16/6, right? That is the minus sign. And then you have another +2. All right. Let's add our positives together. That's going to be 2 and 4 and 2. That would be 8, right? And add our negatives together, and that's -21/6. Now, last time Clark decided to give an answer in improper fractions, so let's do this too. How many sixths is 8? Is Say again? How many?
I was asking what was the question, you said how many sixes in there?
How many sixths is 8?
24.
Okay, 24 6 is 4. Right? 48. So that'll be 48 6 minus 21 6.
You getting 20 what again?
See, 6 will go into 48 8 times. So that, okay, right. Minus 21 6, and that's going to be 27 6. So that is what I'm hoping the answer is. Let's see if we can find. No. I botched something up, and frankly, it's so. Oh. You can reduce that, can't you? Yeah, I didn't realize that. 3 will go into both of those, won't they? 3 will go into 27. Second, 9 times. 3 will go into 6 twice. 9 halves. Yes, we got it right, finally. Okay. 9 halves is your answer, or 4 and a half. Okay. So yes, we did it right, except I didn't reduce my fraction at the end. Okay, you see how that works? Now, to me, the signs are the hardest part of that problem. The calculus wasn't that bad. It was a little bit of manipulation and stuff, but the calculus was pretty easy. The hard part was getting the signs right, because you had minuses of minuses of minuses, and you just, it's so easy to lose track of what you're subtracting, which is negative, and which, so that's why, in my heart of hearts, I hate doing that many steps and having to keep up with the signs that way. But that's the only way to make sure that you get them right. Now, if you're very careful with the other and keep up with how many signs you've got there, it can be done a little bit shorter than that. But man, it's so easy to make a sign error. So do whatever it takes to keep from making those. All right. Any questions on that? What's that? I can't hear you. Okay. Well, let's see if we can find another one. Looks like there's an example 3 in the book. So, let's first see how they did it, okay? Then we'll try to do another. So this is almost like doing another one. We'll just have them do it, okay? So find the area of the region bounded by these 2 graphs. The first step is they drew a figure. That's fine. Nothing wrong with drawing a figure. And it sort of is, I don't remember if Clark said it this time, but he did last time. That's a parabola, but one turned upside down because of the minus sign, but you moved it up by 2. So there's your parabola moved up 2 units, so your vertex is at 0, 2. And then here's the line g of x equal x, just the identity function, okay? Now, if you trust your graph, and you graph very carefully, and you're absolutely certain those are your endpoints, then you can use those. Most of the time, I just do the graphs to just give me an indication of about what it's going to look like. And I don't trust my graphs because I'm pretty sloppy with graphing. Did I say that out loud? Okay, Catherine's here. So we're only missing Charles. So I'm here, but okay. So there is how this looks, and the graph helps you see it maybe a little bit better. Okay, but it's not absolutely clear that this intersects exactly at -2, -2, and exactly at 1, 1. Though those are likely points because they are on the line. The question is, So what we did first was find the 2 points of intersection. I don't know if they're going to do that yet or not. I hope they do, because that is a technique to do. Okay? And then what I did, we tested and see which one of these is greater at some point in between those. And we chose the point 0, and certainly the parabola was greater than the line at 0. So it's going to be greater than that all throughout. Okay. Now, to find the x-coordinate of those two intersection points, this is exactly it. They set f of x equal g of x. And if you remember, f of x was 2 minus x squared, g of x is equal to x. Those 2 points of intersection are where the two functions are equal. So you set them equal to each other and see what we get. And they did it with the minus sign on this side. I don't really care for that, but that's fine. Negative x squared minus x plus 2 is equal to 0. Anytime you have a quadratic, you got to get all the, or higher, get all the variables and numbers on one side, 0 on the other side. Okay? So what they did is a little bizarre. They factored out a minus y, which I would have done by moving it to the other side, or just multiplying both sides by minus 1. That works too. And there's your factorization, exactly like we got, except they have a minus sign in front of it. So that gives x equal negative 2 or x equal 1. Forget about the minus sign. You could have divided it out anyway, okay? So that gives you those two options. Left-hand endpoint, right-hand endpoint, okay? So your A, the lesser of those is negative 2, and the B is your greater of those two to be the positive 1. I'm sorry, I'm losing my voice. All right. Now, what's the area between those two? The area is the difference of those two functions, not where they're equal to each other, but the difference of the two functions. So since we had already determined f's on top, we'll do f of x minus g of x, and then multiply that by our delta x. That will give you incremental areas. We'll sum those up, but actually make that an integral and go between the two endpoints, which are minus 1 to 2. Okay? So that's the difference between 2 minus x squared and x is written there, times your delta x, and that will then reduce or go into being a, I said it backwards, the integral from negative 2 to 1, I said negative 1 to 2, it's negative 2 to 1, 2 minus x squared minus x, okay? And you really don't need those parentheses anymore, or even the brackets anymore. You could just do them without that, but that gives you, and they skipped in a bunch of steps, taking those out and doing things, and they rearranged and put the minus x squared in front, the minus x next, and the plus 2 at the end. Then they integrated and did minus x cubed over 3 minus the x squared over 2 plus 2x. Integrating each of those in their rearranged order. And then evaluate that from negative 2 to 1, sorry. Okay? Now, let's see how they, the hardest part of the problem was keeping the sign straight. So they skipped all those steps to show you how to do that. And just say, oh, and the answer is 9/2, okay? That's the prerogative of being a book, I guess, you know. You can skip all the hard part. Just say, oh, and this produces 9/2. Okay. But we went through and I showed you in gory detail how you do those evaluations. Okay? So that was example 2. I bet you they're not going to do example 3, and they're not going to do example 4, and they're not doing example 5. So you asked for it, you got it, Toyota. We're going to do some more examples. Okay?
So any reason they wouldn't do it?
What's that?
Is there like any reason they wouldn't do it?
I guess they're just saving on slides. I don't know. I do not know. It's all electronic, but I guess they figure there's something for you to do. I don't know. I can't answer that question. Okay. So let's do example 3 here. Goodness, my eyes are so dry. There was something when I was driving in this morning, I believe that's where it was, that, I mean, I don't know if something blew out of my defroster or what, but both eyes, I thought I was going to have to pull over because I was having trouble seeing. And then they cleared up, so I drove on in. Now they're getting dry again, so I don't know what's going on. All right, the region lying between two intersecting graphs. The sine and cosine curves intersect infinitely many times. Bounding regions of equal areas as shown in the figure there. Please look at the figure, or some of you don't have books, do you? Yuck, okay. So I'll draw this. It says find the area of one of those regions, okay? So let me draw the sine and the cosine. All right, we'll do 0, pi halves, pi, 3 halves pi, and 2 pi. Okay? And let's just do this 1 and minus 1. All right, this goes up to 1 there, comes down to 0 there, down to minus 1 here, and up to 0 there. Okay. Cosine function starts at 1 and goes down to 0 here, down to minus 1 there, up to 0 there, and up to plus 1 there. Okay. Now, without drawing more, I mean, goodness, that hurts. This will be 5 halves pi and 3 halves pi. No. 3 pi, okay. Okay. Let's go on again. Cosine comes down here and goes down like this. The sine goes up here and down like this. Okay. Now, what they want you to believe is that that area is the same as this area. And even in my ugly drawing, yeah, they look the same. These are all symmetric. And if you continued on, that would be another one just like this. So, yeah, those are all the same areas. So let's just take the first area. Now, we have to figure out where they intersect. There's one intersection point here and one there. I have a guess of where they are, and I know that's where they really do, but let's find out where they do intersect. How do we do that? This, by the way, is the sine x, and this is cosine x. So what do we do?
Sine equal cosine.
Yeah, set sine equal cosine. So sine x equal cosine x. Okay. You want the points of intersection. Okay. I guess there is a way to do this more logically, but I think let's just ask ourselves, where are they equal? In other words, think of it this way, huh?
Would it be pi fourths?
Absolutely, because the sine of pi fourths is square root of 2 over 2, and the cosine of pi fourths is square root of 2 over 2. We know they're equal there. So this must be the point, and it does indicate pi fourths. And then you want to make a guess what that point is?
You have to be in the, where they're both negative.
which is
Looking by unit circle. Would it be 5?
5 pi fourths, exactly, yeah. And there's that one. So we have our limits now. I was thinking there might be an easier way, but let's just do it that way, okay?
Then, can you also divide by cosine and get tangent equals 1?
That's an excellent way to do this. Divide both sides by cosine x. That is the best way that I can think of right now to do that. X, and that would be where tangent x is equal to 1. You're absolutely right. And where does that happen? At pi fourths and at yeah, but the thing is, this one that's not at 1, it's at minus 1, okay? So, but that still works out okay. Tangent, sine is equal to cosine in the first quadrant and the third quadrant because they're both positive up here, both negative down there. So yeah, so it's the same, yeah. So yeah, that's the best way to do it. That's at your pi fourths plus pi, which would then be 5 pi fourths. Exactly. That's the best way to do it. So this will be x equal pi fourths plus pi fourths and pi fourths plus pi, because the period of tangent is pi. That would be 5 pi fourths. So those are our two things. Now who's on top?
Cheat and look at our graph, we can say that.
What's that?
So if we cheat and look at our graph, we
Yeah.
can say the sine's on.
Sine's on top, exactly. Or what you could do is just pick a point between pi fourths and 5 pi fourths. Say pi or pi halves, either one. And see at pi, sine is 0, but cosine is -1. So yeah, sine's on top. So since sine's on top, our integral will then be, the area would be the integral from pi fourths to 5 pi fourths of sine of x minus cosine of x. There's your height of that representative triangle there, okay? Times dx. The width of that rectangle is dx. And the height is the difference between sine and cosine. Sine's on top and cosine's on the bottom. So can we do that integration? Let me erase some stuff so we can see a little bit better. Since you already did this, did it really nicely. Get those out of the way. Okay. All right, what's your antiderivative of sine? Oh boy. Huh?
2 cosine. 2 cosine.
Where'd you get your 2?
We're talking about antiderivative. Let's take
Got
that derivative. What is that equal?
Antiderivative of sine is what?
So long ago.
So long ago.
Um,
Okay, how about, what's the derivative of sine?
Cosine.
Cosine. Derivative of cosine?
negative sine.
Negative sine. So here we have a sine, so its antiderivative would be negative cosine. Okay? And what's the antiderivative of negative cosine?
Negative sine.
Negative sine. You got it. Okay? We'll evaluate that between pi fourths and 5 pi fourths. Okay.
Would that be point, so that's not minus a negative sign, that's just minus sign.
Okay. If I had said, I'd written down the minus sign and then said, what's the antiderivative of cosine?
Well, it would just be sign.
Been sign, yeah. So the minus, you either say the antiderivative of minus cosine is minus sine, or minus the antiderivative of cosine, which is sine. Either way, they come up the same. Okay. Now we got to evaluate them between those 2 points. Okay. Now, what is the cosine of pi force?
2 square over
Root 2 over 2 is the value, but what sign does it have at pi force? 5 pi force.
oh, it's negative.
Negative. So that would be a minus a negative root 2 over 2, right? Minus, that's there. And what's the sign of 5 pi force?
Negative.
Negative again. Negative root 2 over 2. Okay? Then we're going to do a minus of a minus, which is a plus. And what's cosine of pi force?
Positive.
Root 2 over 2. And then the minus of minus again would be plus root 2 over 2. Okay? So these become plus, those become plus. So you have 4 times root 2 over 2, right? Because you have 4 of them. That would be 2 root 2. So that's the area of any one of those areas there. 2 root 2. Perfect. Do you see how that happens? Say that again. Sine is positive at pi force. But we had because that's the bottom one, you do minus of this. Well, the minus makes those pluses. So cosine is that and sine is that. Okay. You evaluate this thing at that value. Then minus this thing at that value. Right? The fundamental theorem of calculus. So this thing with the minus signs in there, evaluate, those are both negative there, so the negative and negative become positive. Then you subtract this, which that minus makes these 2 plus, and then these are both plus down there. So yeah. Again, the signs will trip you up more than the calculus will, okay? And you have to be very, very careful with this, okay? Now, if you ever come up with a negative area, you know you've done something wrong, so go back and check. And if you've got an area like this and you came up with 0, you know you did something wrong, you know, because areas are always positive. Okay. Now, here we have, okay, there's some verbiage at the top of page 447 that needs to be read. They don't put it in the slides. To find the area of a region between 2 curves that intersect at more than 2 points, first determine all the points of intersection, then check to see which curve is above the other in each interval and determined by those points, and then integrate appropriately. Now, if you want some more insight into this example, you can go to larsoncalculus.com for an interactive version of this kind of an example. So do it if you need to. Let's us see what we can do on this one. Okay? All right to erase this ink? Okay. Virtual ink. Okay. Find the area of the region between the graphs of f of x is equal to 3x cubed minus x squared minus 10x and g of x, which is equal to minus x squared plus 2x. Okay. Goodness gracious, I'm stiff. I don't know why. Okay. We need to find the area of the region between those two graphs. Okay. Now they graphed it for us, and if you have a graphing calculator, that's an easy one. That's the easy way to do the graphing. If you don't have a graphing calculator and you have to do it manually, it's going to take a little more effort. But what do we need to know about these? And let me, this is going back to pre-calculus algebra again. What's the end behavior of this one, f of x? Going down to the left, but up to the right, because see, that's the odd exponent. Remember that? Cubic function, any odd exponent, odd degree is going to be going in the opposite direction. And since the sign of your leading coefficient is positive, it's going down to the left, up to the right. Okay? Now, g of x is doing what though?
Going down in both.
Down in both directions. So at some point, they're both going south. This one's going south faster than that one's going. So g is going to wind up on top, but you know that's going to be way out there. Way out that way, f's going up, g's going down. There the twain to meet. So they're going to intersect somewhere in between. We don't know how many times, or we think they're going to intersect. So that's the first thing we're going to determine. And how do we determine where they intersect? Set them equal to each other. F of x equals g of x. So we got 3x cubed minus x squared minus 10x equal to minus x squared plus 2x. Right? Do the math. How would you try to figure out what's going on there? And also, while we're doing it, let's subtract 2x from both sides, right? So we'll add x squared and subtract 2x, and that leaves us 3x cubed minus 12x equals 0, right? Those add to 0. Now what would you do? I couldn't hear.
Solve the equation?
Yes, yes. How?
By
Say again?
factoring.
Factoring. Okay, we're not at the point of integrating yet. We're just trying to find the endpoints, so the common points. So how does that factor? Take out a 3x, and that leaves you a x squared. Is that what you said? Say yes. Okay. Minus what? You took out an x, didn't you? Yeah, okay. Minus 4 equals 0. Okay? So I know one point of intersection, x equals 0. Are there any others? Can that factor any further? How? Say again? You may have said it right. What did you say?
I didn't see nothing else.
Oh. Okay.
You factor that out anymore because then you don't have like common.
Okay. You factored out the common factor of 3x. Now we have an x squared minus 4. Does that factor any further? Anybody? How?
To be x plus and x minus.
X plus and X minus.
Oh, I thought you was trying to bring something out that,
Yeah. And what is a blank there in each one? What are they? 2 and 2. Right? Difference of two perfect square factors is the sum times the difference of their square roots. Okay? That's equals 0. So what are our zeros then? No, not 3. 3x equals 0. Right? X plus 2 equals 0. Or x minus 2 equals 0. If 3x equals 0, what must x be? 0. So x equals 0 is 1, 0. Another one, x equal negative 2 or positive 2. So you have 3 points of intersection. Now outside those, they don't ever cross again. But inside that, you have actually 3 places. So you have an intersection here, here, and here. They're evenly spaced too. Okay? So what we've got to figure out is who's on top. Now, I suggest pick some number between minus 2 and 0. No, 0 isn't between them. Well, negative 1. Okay, let's do negative 1 and see what f of negative 1 is. That would be what? It's negative 1 cubed. Negative 1 times 3 is? Negative 3 minus what's negative 1 squared? And, oh yeah, negative 1 squared is 1, so that would be minus 1. And then minus 10 times minus 1 is plus 10. Okay, so f of negative 1 is 6, right? Minus 4 plus 10 is 6. Let's see what g of minus 1 is. It's going to be a minus, what's negative 1 squared? 1 plus 2 times negative 1. So it'd be a negative 1 minus 2 equal minus 3. Who wins? F's on top. So between negative 2 and 0, F's on top. Okay, pick a number between 0 and 2. 1. Okay, let's do f of 1 then. That's pretty easy. What would that be? 3 minus what? Minus 1. Okay, that comes out to be say again?
Negative 14.
Negative 11 plus 3.
Oh, negative 8.
Yeah, okay. So f of 1 is negative 8. What is g of 1? Again, it's pretty easy. Perfect. Who wins there?
1 GX.
The g is on top there. It's positive and f of 1 is negative. So we got 2 integrals to do. The first integral is from negative 2 to 0. And this one we put the f on top. So it's 3x cubed minus x squared minus 10x. And then I'm going to subtract from that your g. Okay? I'm going to try to save a little room here. That's minus a minus x squared, so that's plus x squared. And minus a 2x would be a minus 2x. And then you have your dx there. Okay? Now notice here the x squareds go away. And I better write it down again. I was wanting to go on and integrate it like that, but I was afraid that would be skipping too many steps. Yuck, I hate this little screen that's just too narrow. Okay. Let's go and do the other one. Plus the integral from 0 to 2. And who's on top here? The g of x, so that would be a minus x squared plus 2x, plus 2x minus your alpha of x, which would be a minus 3x cubed plus x squared, because there it's minus a minus, and then plus 10x. And then you have a dx. See, I hate it that we run out of room like that. Okay, and again, our minus x squareds and plus x squareds add to 0. All right. Now, let's integrate this as we go. What's the antiderivative of 3x cubed? 3x to the fourth over 4. Then we have a minus. What's the antiderivative of 10x?
10x squared over 2.
Okay, 10x squared over 2, and 10 over 2 would be 5x squared, right? You buy that? Okay. And the antiderivative of minus 2x would be?
2x squared over 2.
Which is just minus x squared, right? That's evaluated from -2 to 0. We'll come back and do that. Plus, okay, antiderivative of 2x.
2x squared over 2.
Yeah, which is x squared, right? Okay. Antiderivative of minus 3x cubed. 3x to the fourth over 4. And antiderivative, I've got to read that last one there. That's a 10x. Antiderivative of 10x would be
10x squared
over 2, which would be 5x squared. We'll evaluate that from 0 to 2. Okay? My nose is itching. I must be going to have company. Okay. Now, notice that we've got here, you got the same integrand except for opposite signs. So our messing with that is just going to, be the same values but with opposite signs. So let's start off. I'll start off and do the 0 part of this one, okay? I'll evaluate this one at 0. What do I get? That's a 0, that's a 0, that's a 0. 0. You need to keep. I don't remember. I think I did lock it up after you left last time, but I can't say for sure. All right. We go to 1140, right? Okay. So when you put 0 in here, it's all zeros, right? So that's 0. So let's do a minus with a -2 in there. That's going to be a minus. Now, -2 to the fourth power is, oh, wait a minute. Did I do that right? Oh, how silly of me. Why didn't I just make this minus 12x, and then this would have been a minus x squared, 6x squared. Is that okay? Sorry. Should have done the same thing here. This would be a 6x squared without that. That would have shortened everything. Okay, sorry about that. Okay, the zeros didn't matter, but it makes a little bit of difference here. So, with a -2 there, that would be, and we got a minus sign because we're subtracting. What is -2 to the 4th power? 16. 4 will go into 16 4 times, and 3 times 4 is 12. So that's going to be a -12 for the first one there. And then we have a minus because you're subtracting, okay? So that's going to be a plus. And -2 squared is 4. And 6 times 4 is 24. So that adds to a 12. Okay. Now then it's going to be a plus here. And now we're going from 0 to 2. So let's do the 2's first. 6 times 4 is 24 minus 12. Same values we did before. And then when you do the zeros in there, you get nothing. So this is another plus 12. And 12 plus 12 is 24. So I hope the answer is 24. Look at that. It is. Okay. Now.
How many problems you gonna have to do on the test?
What's that?
How many problems you gonna put on the test?
At least 10. Okay? And hopefully they'll. Okay, wait. Let me back up just a moment. Those who came in, did you get your test too late? You didn't, because I didn't have them printed off last time. How many did not get test 2? Did you get it? Oh, we're going to swap? You can swap. Okay. That might be a good idea.
We have the second sheet.
Okay, I have one left, and that's for Charles. Okay. That.
It's a charge.
Yeah. Okay. By the way, I think I told you too, and I forgot this. Let me see if I can remember what section each of these comes from. And by the way, let me tell you this as well. The test bank was squirrely. It was all messed up. Evidently, they used the same test bank that they did from the previous edition, and they had added some sections, because the first few sections matched up perfectly, and then after a while, nothing matched up anymore. Okay, so let me go back and see if I can recall what these, so they may be a little weird, but let's see if I can get it right. Number 1 is from section 5.1. Okay? And number 2 is also from 5.1. 3 and 4, I believe, are from 5.2. Number 5 is from 5.3. I think that's the only one from that section. Okay? Number 6 is from 5.4. And number 7 is from 5.4. Number 8 is from 5.5. And number 9 I believe is from 5.7. It may, I think it's from 5.7. Okay? And then number 10 is from 5.8. Okay. Now those were not the numbers on the test bank, because the test bank, it was just all messed up. The first few were okay, but the next ones, they were not okay. And So I tried to get them back in the order that we had done. So hopefully that will be helpful. And if you may notice, there is absolutely nothing there from 5.6, L'Hopital's rule, because there was nothing in the test bank from L'Hopital's rule. Evidently, in this edition, they added that section in. So I wanted to give you one from L'Hopital's rule, but if the choice was my making up a problem, when I make them up, they seem so easy to me, they're always so difficult for the students. So I thought, no, we'll just leave it off. What's that?
Maybe you can make it a bonus question or something.
Well, but yeah, I didn't want to give you any more to do than you had to. So, all right. So let's get back to where we were. So we got this one to work out. Now, what they said, and it is indeed true, if you had just said, well, let's just do one integral and do them both from minus 2 to 2. Well, whoever you put on top, the answer is going to turn out being 0. It doesn't matter which way you do, because they're the same thing, but with them flipped, it's plus 12 and plus 12. If you didn't flip them, it would be a plus 12 and a minus 12, or minus 12 and plus 12, and that adds to 0. So don't just take the endpoints, do it the way we did, find all the points of intersection, label them out, get them in order, and then pick the first interval, see who's on top there, and the second interval, see who's on top there, and then do your integrations that way. Okay. Now, they have another little blurb at the bottom of page 447 they don't have on the slide set. If you're doing integrating with respect to y, so your dy's, that means your delta y, your interval here is this way, so you're integrating from y equals something down here to something up there. If the curve crosses the y-axis, then you have to do, or the two curves cross each other this way, then you have to integrate whoever's on the right hand minus whatever's on the left hand. If they swap, then this one minus this one. So you do have to do the same thing there, but where there it was above and below the x-axis, now it's right and left, rather than above and below. In other words, for dx's, it's top curve minus bottom curve. For dy's, it's right curve minus left curve. The greater minus the lesser. Okay. Now I think we're ready for example. No, wait. Sorry about that. Example 6 is yet to go. So let's do example 6. And this is one in dy's. Okay. Find the area of the region bounded by the graphs of, okay, x equal 3 minus y squared, y, or x equal y plus 1. Okay, the area of the region bounded by those two graphs. Okay, these are obviously functions of y, not functions of x. So the odds are you're going to be integrating with respect to y, because it's going to be really messy to try to get this in terms of x's, because then you're going to have a y squared. When you take a square root, you get plus or minuses. That's going to be a mess. That would be easy to change back to y as a function of x. This would not be. So let's leave them in terms of y. So first thing we have to do is figure out what?
Where are
The points of intersection. Okay? So how do we get that? Set them equal to each other. Since the x's are the same, let's do 3 minus y squared is equal to y plus 1. And then how would you solve that one?
Subtract y, subtract 1.
You could, but I'm lazy and don't like to do it that way. I want to add y squared and subtract 3. Add y squared and subtract 3. And that gives me a 0 here. And this gives me y squared plus y minus 2. I just don't like leading off with a minus y squared. I like my leading term to be positive. It's just easier for me to do without making mistakes. Okay? Then what would you do? Hint, hint. Factor. And what does that factor as? Y times y, right? Okay. Where do you look next? Sign of the last term. That's negative. That tells you these are positive and negative. Positive 2, negative 1. Perfect. Check it. Y squared minus y plus 2y. That'd be a plus y minus 2. Yes, that works. What are your endpoints then? Okay, y is equal to negative 2 up to y is equal to 1. So you're going from negative 2 to 1. Now, we got to figure out who is greater, the first x or the second x. So pick a y in between negative 2 and 1.
0.
Oh, wow, I was going to go with 3 halves, but okay, no, it's outside. Okay, we'll go with 0. All right. The first x, what is that one? Y 0? 3. The second x? 1. Who wins?
3.
The 3. Okay, so that's going to be the right-hand one. So our integral here is going to be what? And it's going from negative 2 to 1. What do we do next? What's our integrand? 3 minus y squared. Minus.
Y plus 1.
Okay, if you put it in parentheses that way, without that, just do a minus 1, right? Put it in parentheses, it's minus y plus 1. You multiply through, distribute, then it becomes that. I'm being lazy, sorry. I'm not sorry, I'm lazy. Okay. All right. dy, because that's your width. The length is the difference between those two, and the width is your dy. And you're summing those from negative 2 to 1. So let's clean that up just a little bit. The integral from negative 2 to 1 of 3 minus 1. 2 minus y squared minus y. There's no reason to change that. Let's just integrate it like that. Can you integrate that? Antiderivative of 2. What's your variable of integrate? 2y. 2y, okay. Yeah, I thought you.
I wrote down X.
Okay. Next, antiderivative of minus y squared, or minus the antiderivative of y squared. What's that? Y cubed over 3 minus y squared over 2. Evaluate that between negative 2 and 1. Okay. I'll start with the 1 over here. I'm going to give as much room as possible here. 2 times 1 is 2 minus 1/3 minus 1/2. Then minus a minus, so that's going to be a minus 2 times a negative 2. I'm going to write this one out because it's so easy to make your sign errors. So this minus here is your, because you're doing the lower one, you know, Alpha of A minus alpha of B, okay? Or alpha of B minus alpha of A. So that's where that minus came from. 2 times a minus 2 minus, and what's minus 2 cubed? Negative 8 over 3 minus, and negative 2 squared over 2 would just be a 2, right? Now let's see if we can fiddle with our signs. A 2, and this is 1/3 minus 1/3 minus 1/2 is minus 5/6. We did that before. That's 2, 6 minus 3, 6 is minus 5/6. So we got that one done. Now here is a minus times a plus times a minus. That's going to be a plus 4. You see that? Okay. Here we have a minus times a minus times a minus. So that's going to be a minus 8/3. But let's make that 16/6. Is that okay? Okay. And then we have a minus times a minus, which is a plus 2. Right? The minus on the outside, the minus on the inside, that's plus 2. How did I get 16/6? Yeah, I knew I had this one in 6, and this is a minus 8/3. Minus a minus a minus is minus 8/3. But go and get it into 6. Make that 16/6. Okay. Now, let's see what we add to. 4 and 4 is 8. Seems like we've done this before. 8 minus 21/6. I swear we've done this before, haven't we? Earlier on?
I think so.
Yeah.
I don't know if it wasn't.
But anyway, that was 48/6 minus 21/6. That was 27/6, which is 9/2. They love that one, don't they? Okay. Completely different problem, but exactly the same answer. Okay. Wow.
That's weird.
Okay. 9/2 is your answer. Don't know where. Yeah, there. I wrote it down. All right. So that was example 5. Now, if we had done with respect to x, it would have been a mess. Now, I didn't draw the graph for you, but this is a horizontal parabola. Vertex at 3, and it's opening this way, okay? This is just the line, okay? So, it's awfully heavy, okay? So, here's your line, and there's that parabola, vertex at 3. So we were doing dy's, and it works perfectly fine from -2 to 1. Y is equal to -2 to 1. And all those work perfectly fine. One interval will do it. However, if you had done it with respect to x, first, remember we'd have that plus or minus thing here. So for that part, you have to go from the upper parabola to the lower parabola, minusing a minus, so that's a pain. And then for this part, you do from the line minus the parabola, which isn't bad, except you still have the issue of the square roots and stuff in it. So it's so much easier to use the functions they give and to do your dy with that. Okay. Now this next part here, do we have time for it?
We have 3 minutes.
3 minutes.
It'll be close.
Okay. Let me just turn to that slide here. Okay. Integration as an accumulation process. All right.
That wasn't number 6. Did they
What's
skip
that?
number 6?
I'm sorry.
I said that wasn't number 6. Did they skip number 6?
No, that was example 6. That was the parabolas.
Okay.
That was example 6. with the DYs, that was example 6.
So it's example 5.
Yeah, it looks like
Okay.
example 1. That's what I'm
What's
saying.
that?
It looks like
Oh, I'm sorry. I couldn't read. Yeah, that was example 5. Example 6 is in the next part. So we haven't gotten that. My eyes aren't focusing well, and I thought that was a 6, but that was a 5. Yeah, example 5. Okay, we'll pick up with this next time because I do want to give you, because I knew you'd be very disappointed if I didn't, some homework exercises. So let's go to the homework exercise. Oh, I got one more thing to do. Do any of the odds 5 through 9, okay? They're all at Calc Chat, 7's at Calc View. Do either 11 or 13 or both. They're both at Calc Chat, 11's at Calc View. Do any of the odds 15 to 27. They're all at Calc Chat, 17's at Calc View. And I'd say do 29. That's a lot like the one we just did. It's at Calc Chat and Calc View. Then do any of the odds 31 to 35, they're at Calc Chat. Any of the odds 37 to 41, they're all at Calc Chat. 37's at Calc View. Do any of the odds, either 43 or 45, they're both at Calc Chat. And either 47 or 49, they're both at Calc Chat. Do 51, it's at Calc Chat. And we'll pick up the rest of those next time. All right? Good deal. And have a good weekend. Of course, working calculus problems will make it a good weekend.
Can I print my...
What's that? Yeah. Oh, you're going to say, well, you wouldn't have had to put them on both pages. That's fine. All right, good deal. All right, let me turn this off.